Good morning. Ooh, it's loud. My name is Andrew Tygielski. I'm with TechMasters. TechMasters, like Teledyne and a number of other people, were located across the United States, but our NASA focus is located in Huntsville, Alabama, along with our corporate headquarters. We are a small business, just under 300 people, and at the same time, we have integrated a number of experiments on space station. Worked with NASA for about 15 years. We've been around for about 22 years. Next slide, please. Again, what we can tell you is we've worked with researchers who have been in the exact same position you have been. We've flown a number of payloads on the shuttle and on space station. The first two experiments that ever flew in MSG, we actually built that hardware, starting with the researchers, the scientists, to help them with their science concepts. How are you going to do this in space? We stepped them through that entire process, all the way to the point where they were getting their data down and figuring out what they're going to do with their science information. We even help them with post-flight analysis, writing reports, and doing presentations too. Next slide, please. On the flip side, we also support NASA, as these other contractors do, in helping integrate those experimenters. When the researchers come with their hardware to space station, we have that insight from the NASA side on making sure they meet all the requirements and that they get transported and operated properly. So we kind of see it from both sides of the fence, make sure we can get you through the process with the fewest amount of problems. Next slide, please. And basically what that process is, for a researcher or a scientist, it's just a simple, you have your science concept that you start out with, and then you've got to figure out how you're going to do on space station. So we look at existing hardware, maybe commercial hardware off the shelf, adapting that, or possibly building new hardware. We've done all that before. Make sure that we can demonstrate on the ground that you'll be able to accomplish your science objectives, come up with a prototype if necessary, prove it, and then we start into that second phase of building your flight unit, making sure it has all the proper documentation that NASA's going to want to see to make sure you're verified to fly, all the way to where you're qualified to fly, and we test you through that. We've also will sit with you on console. We've actually had people operate on console, send the commands to the space station, look at the video, make commands, work side by side with the researcher or the scientist right there at the console as well. And then even post-mission support, help analyze the data if necessary, archive it, put together presentations. So again, we've been side by side with people who are exactly in your position. How am I going to get through all this NASA research? And we know very well what it is that NASA will do for you that you don't have to worry about. And we know also those services that NASA can make available to you if you need, and then the work that you have to do on your own. Next slide, please. That first section, of course, developing the payload, starting with those science concepts, looking at those candidate facilities, the hardware that already is available. Can you already do it in something that already exists? And are you looking at too many resources? Someone earlier asked, well, how much crew time is available? How much power is available? Having been down that road before, we know kind of what are good rules to live by so that you don't kind of price yourself out of the market right off the bat. What's reasonable to expect on space station. And then once you get that idea of how you're going to operate, kind of analyze it. Will it work? Will it work with commercial hardware that you've adapted or new hardware? What kind of testing plan? What kind of safety implications do you have right up front? All those things that you're going to need to know, all the way to the point in this phase where you've got a prototype that shows, yes, we're going to be able to do this science on space station. And once you're done with that, next slide, is the development of the flight hardware, which we've built a number of pieces of flight hardware, operated very successfully. In fact, I believe it's PFMI had operated probably about 10 times more than the investigator had hoped. It was left on orbit when the shuttle was down for about a year and a half, and they kept coming back to him asking, well, can you operate more? Can you operate more? And he wound up with more science than he ever dreamed of having. But again, it operated. The flight unit, we actually build the hardware, check it out, verify it, work with the facility, whatever it's going to go in and integrated. Primarily, we've done glove box payloads for the mid-deck glove box and also for the space station glove box, equally as suited to do other carriers as well. Next slide, please. And then again, the operation support. A lot of times, NASA does most of the work for you. You sit on the console making the science calls, and we've sat and done that as well before, looking at the data coming down, if there's any real-time decisions, training the investigator if they need to understand what's going on. A lot of it is sitting on consoles and operating. And then the post-flight analysis of the data, working with the investigators to make sure they understand the data that was coming down, make sure it was interpreted properly, and can lead to science results, because generally that's what they want to focus on. Next, please. The very first NASA experiment that operated in glove box, PFMI, is a piece of hardware that we built at TMI, integrated it into the glove box. Again, like I said, we were on both sides of that fence. Operated very successfully, like I said, and it was called into additional service many times. Next, please. And as it turns out, the second NASA payload to operate in the glove box was SUBSA, similarly a furnace that operated in the glove box. Again, we built that hardware at TechMasters, helped integrate it, and flew it, operated it. Next, please. Here's a list of all the investigators, the scientists that we've worked with over the years, in their affiliation, the hardware that we built for them and operated. Next. Again, TMI is a small business, qualifies us for a number of things, but we have a tremendous customer base, business in just under $100 million a year, typically. We've worked primarily with military customers, a lot of commercial customers, and our focus with NASA, of course, is at Marshall Space Flight Center. Next, please. Again, a small company, most with technical degrees, all available. We have, I think, the resources necessary to pull off building the spaceflight hardware we've demonstrated many times, but we're a small enough company, we think, to where we can react a lot quicker than the larger ones. And next, last. So if you want to go to space, we can help you fly. We've done all that before. But in particular, if you think it's something that you need to do in the glove box, we have that unique experience of building those payloads that go in the glove box, as well as, from the NASA side, supporting the integration of those experiments. So we'll be able to help you hopefully get into space flawlessly. Thank you.